actually graph them. So there's a couple of different ones that you're going to get. So really, you will get one in the form of an expanded cubic, okay? And if it gets like this, there's always going to be at least one factor. You're always going to be allowed to get one factor, which if you get one factor, a factor is the same thing saying it is the x-intercept. Once you get one factor, then you'll get a linear factor. So we're going to call that a linear factor, x minus 5, and then you may have a quadratic, okay? Now this quadratic may or may not have factors. What you need to do to this quadratic is check out the discriminant. I mean, see if you can factorize. If you can factorize it quite easily, yay, factorize it. If you can't factorize it quite easily, check out the discriminant. If the discriminant is a negative number, clearly you can't factorize this any further. However, if the discriminant equals 0, well, it's going to be a perfect square. If this discriminant equals a positive number, well, then what you're going to find is that you can factorize it. So put it through the quadratic formula and you get 2 more factors. Depending on how many factors you have will depend on the shape. So let's just have a quick look at some of those ones. If you've got one factor, okay, the shape can look variable. So if you've got axes, okay, if you've got one factor, it could sort of look like this, okay? It could also be like coming up this way and then have a big turning point above the axis and come down. Either way, we don't know quite what it's going to look at. We're going to look at these like turning points and points of inflection later on in a different chapter. And all this concept of finding x and y intercepts will come back again. So you really need to know this. Otherwise, on further down, when we sort of get into calculus, you're going to struggle with this. That's one factor, okay? So it could be that. These ones are obviously going to have an equation of y equals x cubed because they're all going in the positive direction. Now, you could also have another factor, something like this. Okay, that's got one factor. It's still a cubic. You could also have something like this, comes down and goes like this. That's going to want to have one factor. This is going to be in the form of y equals negative x cubed. And these are going to have, plus x squared or plus x and whatever your constant term. Same with these. This is going to be negative because it's going from the top left to the bottom right. This is going from the bottom left to top right. So just think of your y equals mx plus c. Notice this is an odd power because this is an odd power and it's the highest one. M, if it's positive, will go that way. M, if it's negative, will go that way. This actually still applies to the same thing of if I have x to the power of 5, it will go from the bottom left to the top right. I've got y equals negative and say the highest power is 5, that will go that way. All right, so that's basically what we're looking at with these ones. So if you've got, we've just looked at, if you've got one factor, okay. So if you had one factor, when you factorize it, you will get factor. And this one, you will get a quadratic. And what you'll find is the discriminant will have to be negative for the quadratic. Now, this is my short notes. I'll probably recommend, if you get this, cool. If you don't, or if you're kind of getting it, this is pretty much a quick summary note of everything you need to know about if there's one factor and when we're factorizing. Because we're going to kind of blend F and H together. So we can also have 3 factors. So we're going to look at 3 factors. Again, I'm just going to look at the positive and negatives. Like we looked at positive would go this way, negative would come down, so that's fine. But if you have a positive and you got 3 factors, that obviously means this could go something like this, right? It's going to go awesome, right? It loves it, okay? So this would this could be a possible solution for this equation, y equals. What you're going to find is you're going to have let's go with x plus 3 again. And then you're going to have a quadratic in here. And what you'll find is you could factorize this. You might be able to just look at it and factorize it. If you couldn't, when you do discriminant, you're going to find the discriminant is going to be positive. Therefore, you can actually factorize it, right? Because if you've got the discriminant positive, you can just put it through the quadratic formula. So then you'll find, oh, actually, there are 2 other factors. And what you'll end up with is 3 different type of factors. 1, 2, 3. So that would have to be a negative and negative. So that might be I don't know, that's 3. That might be -1. That might be -4. That works out nice. Okay, and that's basically if I give you, if I expand this and I write it as a general formula, hopefully you can factorize it. And then you can actually then go, oh, there's 3 turning points. Now, if you know there's 3 turning points, this formula would have been, let's just quickly check out what this would be. On your CAS, we'll show you how you can actually expand this as well. So if you want to do it quickly, you can just plop your CAS, go to main, edit. Okay, so I'm just going to go x, what are we, plus 3, x minus 1, x minus 4, and we're just going to highlight this. We're going to go interactivity. I'm going to highlight all this with a stylus. Actions, I think. We're going to go calculations and we're going to do expand, advanced. There should be an expand one in here. Expand, 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 expand. This is great teaching right here. I don't even know how to use the CAS right. Jeez, I haven't done this in a while. Here we go. Transformations, expand. I knew I'd find it eventually. Thank you very much. There it is. So this would have been the original equation. Y equals x cubed minus 2x squared minus 11x minus 2x squared minus 11x plus 12. Now, what can I tell from this in expandable form? I know this is basically what you're going to do. You're going to get a question like this, and it's going to say, hey, sketch the graph of it. And you're like, oh, what? So you're going to go and go, well, let's look at the factors of this. Well, this is great. You know, we don't have to use the rational root theorem because, you know, we don't have a number in here. We're going to look at the factors of 12. Well, if you put 1 in here, 1 minus 2 is negative 1, minus 11 is minus 12, plus 12 is 0. You're going to be like, sweet. And you'll actually get your first factor of x minus 1, okay? And then you'll do long division or division by inspection. And then you'll get, you know, this, you'll have an equation that will be, you know, y equals x minus 1, okay? And you'll have a quadratic, and then you'll find that quadratic you could actually factorize, and then you're going to find the other factors are x plus 3 and x minus 4. Notice it doesn't matter which way you write these are all the same factors. Once you get to these factors, there's two things you need to do. Well, you know that your y-intercept's plus 12, so you're going to put these points on here. You're going to put a point here. We know that that is 0, 12. We also know that it's going to intercept at negative 3. So you're going to put a point here and you're going to go, well, negative 3, 0. You also know it's going to intercept at 1. So you're going to put a point here on your graph, 1, 0. And then you're going to put a point at 4. And you know 4 is here, and that's going to be 4, 0. Now, one other thing is, how do I know how my graph's going to go? This is really important with the positive and negative. I know that this is a y equals positive x cubed, okay? This is a positive number, there's positive 1 in front. I know that goes from bottom left to top right. So the first intercept, bottom left, it's going to have to go through the intercept here. And think of, obviously, if it's going through here and you've got 2 points here, it's going to have like a turning point, roughly around about halfway. Now, it's not like a parabola, it's not exactly halfway, but it's around there. So you're going to go up, come down, and then it's going to hit this point, and then shoop, come back up, and then go up there. So I'm not too caring about the shape of your graph, except you should know that it shouldn't be coming this way, because that would have to be a negative graph, and that would be a quartic, right? So hopefully when you actually get your points, you kind of understand about it. So that's how we're going to graph these just for the moment. We're not worried about these turning points. As I said, later on, these points that are turning, we're going to figure these points out later and give those later on in the chapter or another chapter. We're going to start looking at how we find out these turning points. You're going to have to recall all this information about how to find the x and y intercepts. So that's really where we're going with it. So in this chapter, that's all we want to do. We just want you to be able to graph that. Now, so when we're looking at 6F, you're trying to actually, factorize these cubics, and you want to do them. There's two things you need to think of. You need to first think of, well, you need to look at what is in front of my x cubed. Is that positive or negative? If it's positive, we know the graph is going to do something like this. If it's negative, we know the graph's going to do like that. Now, this is if there's 3 intercepts. If there's 1 intercept and it's positive, right, you could draw it like this, okay? So you know it's going to be plus, that's going to be 0, 3, 0, negative 3, I should 3, negative 3, 0. And some people will be like, well, how do I know if it's got the squiggle above it or below it? Don't worry. I don't care if you draw it like that, or I don't really care if you draw it, like this. Okay, It should have like some sort of point of inflection. Notice, you could even draw it. I'll do a smaller one here. I mean, you could even do it like, ooh, it doesn't really turn. It's got like a stationary point of inflection, which it wouldn't have a stationary point of inflection because then you could do a perfect cube. Let's just say it's got a smaller point of inflection. And as long as it goes through here, I don't care. What you could know though is you would be able to know your y-intercept. Okay, so as long as you still check your y-intercept, so when that's an expanded term, you'd know it. Now let's just say if this is my quadratic for this was x squared plus 2x plus 3, I can see straight away what my y-intercept is. It's going to be 3 times 3. It's going to be 9. So that would have to be, because that's the only one I'm going to get the positive term, would be 0, 9. Okay, so it should be still going through the y-intercept. All these graphs will have a y-intercept. I mean, if you think about it, they have to go from left to right, unless they've got a restricted domain, then they won't. But in terms of these ones, they all will because they don't have restricted domains. So we've looked at what happens if you're always going to have one factor. We've looked at if the quadratic's negative. If the quadratic's, the discriminant of the quadratic, if you can't factorize it easily, put it in the discriminant. If it's negative, oh, well, I can't factorize it. Oh, that means it's only going to have one x-intercept and it will have a y-intercept. Just make sure you have both of those and the graph's going through it and it looks like a quadratic, you'll be right for the moment. If you get the one-intercept, the one factor, you find the number, it equals 0, how you count it, bingo. You can do long division, box synthetic division, box method, or by inspection. Then you can factorize, you'll get to a quadratic. And if that quadratic you can factorize, or the discriminant's positive, which means you can factorize it, you can always put it through the quadratic formula. You're going to get two other factors. When you've got those two other factors, you're going to plot them on the graph with your y-intercept as well and draw a graph. Be careful if it's positive or negative. Lastly, and the only other one that we've got, is when you end up with a situation, it can come about a couple of ways, of a graph. Let's just do a similar one to above. Say you found out, oh, x minus 1, if I substitute 1, I get x minus 1, as a factor, because if you put 1 in, it's x minus 1. And let's just say then you put in the quadratic formula and you get x plus 3 and another x minus 1. So what does this mean? It means you've actually got two of the same intercepts here, right? So really I could rewrite this. I could have actually, I've got x minus 1 squared x plus 3. I mean, another way you could have done it, right, is you could have actually just, I don't know why, but you decided not to put in 1, or you didn't quite calculate it right. And then you find out, oh, if I put in x minus 3, it gives me a factor. And then when you put in x minus 3, what you would have found, you would have actually had a quadratic here at the end, which is going to be, it's a perfect square, x minus 2, x minus 1. And you're like, hang on, this is a perfect square. Okay, so you realize that actually turns into that because, that's x minus 1 squared. When you get the same factor twice, this same factor actually is a turning point on the graph. Exactly the same way as if I said to you guys, hey, draw this for me. Well, you're going to go, oh, well, here's the point here. If it was a quadratic, it's like this, right? However, what we need to be careful of in this case is that it could really be a positive or a negative. So it could be that, or it could be like that, the turning point. And we have to pay attention to what this graph would look like. Again, I can see that this is going to be a positive x cubed because if I expand out my x's, I'm going to get x cubed, right? I mean, I can already tell. So I know this is going to be a positive graph. It's got a turning point at x on 1 and x minus 3. Okay, so I'm just going to put my points on here. So I know I've got a turning point at 1. I know I've got another intercept that actually cuts the axis. So here it only touches the axis at x1, and it's going to cut the axis at x minus 3. So we're going to have minus 3, 0, and we're going to have 1, 0, where it touches only. And then I've got my y-intercept of what? Negative 1 times negative 1 is positive 1 times 3 is 3. So we've got a y-intercept here at 0, 3. Now I know it's positive, so it's going to have to go up here, come down, and then it's going to touch this axis and then just go back up again. Okay, so in this case, it is that way. So it's going to come up, come down, and then touch back up and go like that. Okay, and it's going to be good. I probably should have, yeah, that's okay. I probably should have brought this down a bit more. probably, it's not really, that's too much of an arch. The arch, this is a better sort of arch going with it. So that's sort of where we're at there. Just want to show you, like, so that's, okay, that's the turning point going this way. I just want to change this equation just to show you how it could be a turning point underneath, okay? But it's still, you know, because obviously this one's gone with a turning point like that, which makes sense because it's like that normally. But I'm just going to change my equation up. I'm just going to write, if we've got y equals, let's just go with x minus 1 all squared. So that's, you know, I've got 2 of these factors, right? And then I've also got, let's go with x minus 3. Hey, that's cool. Let's stick with the same thing. So instead of positive 3, we've got minus 3. Well, what does that mean if you think about it? Well, if you expanded this, it'd be -1 times -1. The y-intercept would be +1. That would be minus 3, right? So that's going to be my y-intercept is going to be 0, -3. Hey, notice I'm using coordinates, guys. I love it. Those people who still aren't using coordinates on the test. -1, it would touch. I'm getting really small here on the graph. I'm going to make this a bit bigger. I do apologize. Let's go really big. Okay, there we go. Okay. I'm going to get rid of this thing too. I just want to use a bit more room. Okay, so we've got y equals x minus 1 all squared, and we've got x minus 3. Okay, what this is going to look like, obviously you can understand that we're going to have the negative intercept. And we've also then got a turning point here, right? 0, 1. And then we've also got it cutting through the axis, and it's always good to use this terminology because it helps you graph it, like, oh, it turns here, but it cuts there at, sorry, that should be 1, 0, 1, 0, 3, 0, right? So now if I think about it, if I expanded my x's here, it would still be an x cubed, right? And if I expanded my constant terms, well, -1 times -1 is +1 times -3 is -3. So really, that's what I'm doing to figure out what the shape looks like. This tells me the shape is positive or negative. And this tells me when I expand that, the y-intercept. So that's what I'm looking at, really. So now if I think about this, well, it's going to be positive. So it has to come up from the bottom and maybe do a twist and then come back up. Well, it turns on this point, remember? So this is where I was saying before, you know, it could always have a turning point that actually comes back down, and then it's going to go up again. Okay, so notice this one's going sort of, it turns, it touches, but it comes back down. Where this one, because obviously we had it first cutting at -3, well, it's cut through -3, it comes and turns up. Where this one, well, it doesn't cut till +3, so it's going to come up, turn, and then come back down. I don't really like the way I drew that. I'll just try to draw it again. And then that's better, because it's a bit more, that's probably a bit more sort of flowy, how you'd typically see a cubic. That was just way too sharp here compared to it. So really, the degree of this bend here should be pretty similar to the degree of this bend here. So notice how like this degree's gone really sharp, and then this is like really flattened out. That's why I didn't really like this graph. That's why I like this one. So if you look at this one here, sort of like it has a nice kind of curve. The consistent change in the gradient here is pretty much the same as the gradient change in there. Where it's sort of going from positive to 0, then it's got to go into negative gradient, and it sort of, you know, just flows nicely. So that's pretty much it, how it is. Really, it gets, you know, even if you've got a number in front of here, if it's +3, I mean, that's fine. You should know how to factorize these ones, but still, even if it's +3, we know it's still going to have those ones. So really all you want to look at is you want to look at what your y-intercept is. You want to put a point there. If you get 1, let's just quickly review this. You're always going to get one factor. If it's positive, it's going to go from the top bottom left to the top right. You can always get your y-intercept, like no matter how. You'll expand out, you know, once you've got your one factor and this one. All these questions are already written for you. If it's already written in expanded term, well, it's already telling you what it is. It's this one here. You're going to get one factor. You're going to get a quadratic. If your quadratic discriminant's negative, well, you're only going to have it cutting the graph once. The quadratic's positive. So the quadratic discriminant's positive, I should say. You're going to get 2 other different factors, right? And that will be fine. And then you may have 3 different factors. If you've got 3 different factors, well, it's going to cut those graphs at different points. Don't forget about your y-intercept. Sometimes you still have a positive one, right? And what you'll end up with is you might end up with, because you found positive, you know, this one here, you found out what this is, okay, x minus 1, and your quadratic here would still be, your discriminant would still equal positive. And what you'll find is once I've actually factorized that, I've actually got two of the same factors. If you do have two of the same factors, that's a turning point. Alternatively, sometimes you find a factor, and then if you put the discriminant in here, you'll find it equals 0. Now, if the discriminant equals 0, that means it's a perfect square, okay? So sometimes you'll get a discriminant where it's positive, and you'll still have a turning point because you found one of them, and then there's a repeat of the factor in that quadratic. Other times you'll find a factor, and then you'll find, oh, my discriminant is 0. Oh, this is actually a perfect square, and it's the same thing, okay? Really just try and factorize it down to as far as you can. If you get two of the same ones, it's a turning point. If it's three different ones, they all cut the axis. All you then need to know is your y-intercept and where it goes. And that is pretty much it for how we graph those. Is there any questions on those ones so far? Besides Ryan his Wi-Fi, but that's okay. We will make sure you will have this. I don't think there is. So that's pretty much what it is. This does get really tricky with it. One other thing I'd suggest is that you do put one other point on your graph. Use a bit of common sense where you can find it. So you might want to choose a number that substitute nicely into it to sort of show the dilation factor. So I think everyone's pretty good with that. The only other way, really what happens later on as well, so that's really, F that we're looking at. Sorry, that is, yep. That's F, that one there. So the other thing that you can look at is that's, if it's in factorized form as well, is in H, it's pretty much similar to that. Except you're sort of reversing it. You've got to find the actual equation. So, I mean, if you, with 6H, you're actually going to be given a question like this, and they might give you a turning point. Well, if I know this cuts the axis in 3 areas, all I'm going to do here is write out y equals 3 plus x plus 3, x minus 1, x minus 4, and put a dilation factor of a out the front, okay? What I can then do, right, is then substitute another point in on the graph to find out what it is. And that's pretty much it. I mean, in this case, you won't because you've got 0, 12 in there anyway, and it helps you. So that doesn't really matter. So that's sort of where we're going with that. We will come back to 6H a bit later on. I think I might leave it there. I'm just going to stop the recording. How do you guys feel